Good morning, everyone, and welcome back to our channel. Here we are again with a new example. As for Sinutrain, let's do a tutorial. As for the piece you see on the right, as you can see, this time we are also staying within the realm of pure turning. I know that some of you have already asked me why I communicate with some of you through YouTube to also consider the topic of milling. We will do it. Certainly, I've already made a video that, if you haven't seen it, I recommend you check it out, titled Let's Play with Sinutrain, where there's a bit of milling, even though I wouldn't really define it as such. A real tutorial. What's going on here? Here we are, a real tutorial, but it's just a little game. Today, however, we're talking about turning. Let's start by walking, and then we'll run. So, let's start, as always, with creating the program. So in Program Manager, still in the subfolder Parts, New. Let's call it Hub. I also have little imagination when it comes to names. Let's call it Hub. We give it the go-ahead. As you already know, it creates the simple subfolder. Then, as always, it asks if you want to work in G-code or ShopTurn. We give it the go-ahead and create what is our actual program. The first request we have is simply to create the blank. So we work in G54. Our 0 actually corresponds to this area. That is the face of the piece that is farthest from the self-centering XA. You can see that we have the table in another format, meanwhile preloaded with the data of the last piece we entered. So it's still a blank with a diameter of 80. We have a stock allowance in Z of 2 mm. Yes, it's the length of the piece. In this case, 110. It asks for the negative, and ZB is indicated as 101, so minus 101, the SOM overhang from the clamps of the piece. Everything else is typically speaking left as we find it, because in most cases normally nothing changes as it is. We don't have any particular issues with the detachment from the piece, so that's fine. We accept it, and we've entered our simple code. All right, let's start with what is the first machining. So a cheekiness of the piece, cheekiness that we do no more and no less, as we have done last time. So, with our soft key straight circle, so straight, attention, interruption, before, moving, we have to call the tool, so tool. We select the tool and go and get the tool with which we will then rough out the piece. Since this piece doesn't require any particular roughness on the top, we'll chamfer it in one go, since we only have 2 mm of excess material. We chamfer it at meters per minute. I would say 180 for a turning operation. We accept it at, and here we write straight. So, move quickly. Do, say do, that is outside the piece. And at Z0, a movement that we will execute quickly from soft key. We accept it. Let's insert another straight line. And we go to X1.6, since our tool has a radius of 0.8 to avoid leaving a turning bevel with an F of 0.3. It can happen that with some materials going to Z0 with a very high feed rate at X0, in this case minus 1.6, that is in the center of the piece, with a very high feed rate can cause tool breakage. Nothing prevents us from writing. At X0, in this case minus 1.6, that is in the center of the piece with a very high feed rate, you can cause tool breakage. Nothing prevents us from writing here X20, F2.3. Except, then, insert another straight line, X1.6, F0.15. It shouldn't happen, but if we have a tool that's slightly low, even just by a tenth, it can happen. So we need to slightly lower the parameters. All right, let's move away. X120. See? Thank you, 20. Quick, accept. Great. We just did a very simple chamfer. Ah, okay, no. I was building it. I said there's something wrong right away, because I saw the spindle on one side and the piece on the other. I have the program control at Canon, that's why. Perfect. You see that if we press our start button, the tool comes in, starts spinning, and chamfers. Too fast, the program control allows me to modify the overrides. Override that you see here. Back, and start. And let's see a slightly slower machining. If it's too fast for us, perfect. Still in program control, I can set it to single block, go back, and press start, 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 you see. Every time I hit start, we get the reading of a block. Perfect. Program control, let's remove the single block and go back to our little program. Great. What we need to do now is create our profile. So, turning, A, profile. Here we are, new profile. Let's enter the name. Let's call it profile again, because we have so much imagination. And we say accept. All right, where do we start from? This time, we start from x0, 0, that is, from the center of the piece. I usually chamfer and then rest here, but let's do something very educational. We accept, and let's start. Working. We need to move upwards. So, arrow, up, down, X. You see it's a 16 and a radius of 2, so X, 16. Modify the chamfer to a radius of 2, except radius unmarked due to lack of direction. Press soft key left right, Z16, no chamfer or radius, except, and we've moved into this area. M24, move up to X. Now we're going to work. And we press the soft key left right, Z16, no chamfer, no radius. So we're not specifying a dimension here. And we accept. And just like that, we've moved into this area. At this point we have an M24, so we're going to move up to X. 24. Heaven forbid, besides, it's already marked. We should never start a thread with a sharp edge, so a 2 mm chamfer. We accept. At this point we move to Z38, using the right-left soft key, Z38. No chamfer as a result. We accept. And now we're going to move diagonally. We give it the only dimension we have, which is x20, and we're forced to give it an alpha. So here it is. I would give it this, alpha. 45. Chamfer, we don't have it, and we say accept. The emission has been cancelled. Geometry value, contradictions. I apologize. In this case, we need to give it the alpha 2. 45. Except you see it did it, not alpha 1. So, I assume, I don't know why honestly in this case, so alpha 2. Because alpha 2 is given in. Depending on our movement, 225 is alpha 1, which is the total opening of the angle compared to the classic angle 0. You see 2 on 25, but we gave it 45. We were going in this direction, and we opened up by 45 degrees. Explanation given. This is something, for example, that I didn't remember and didn't know. But as you can see, we get there. We need to finish with a radius of 1 to the left up to z minus 53. You see that we are at absolute 53. We have a radius of 1, so the chamfer becomes a radius and becomes 1, except, and we have arrived. Here, perfect, x36. So we go up. Here we go, x36, and we accept. All right, now let's work with alpha. 1. So we give it the inclination, and you see that we're missing some data. What data are we missing? We're missing the diameter and the zeta. The only data we have is 14.8833. So, in this case, we give it alpha 1, and we give it as the opening from angle 0, therefore. This line is angle 0. We open up in this direction. You see? It's 180 minus 14.833. So, 1, 6, 5. I put the dot. If it's not the dot, it will be the comma. 1, 6, 7. Okay, we give it, because I don't like having a gap. Or edge here. I set a radius of 0.4, and let's see if it generates an error. 0.4. Accepting it doesn't generate an error, but you see it creates a line, and it's indeterminate. Okay, now we need to go and perform a circular interpolation for which we have a good amount of data. So, circular interpolation, rotation direction to the right or to the left. It's definitely not this because we're working in this direction. So, this is it. Perfect. Radius. We have it. The radius. Here it is. Radius 13. Then x. Of this x, we have nothing. So of this z, we have nothing, which are the final z and x. What is it? It's absolutely the position of the radius. So 60 k still absolutely is the position of the radius. Anyway, I hope you understood. The position of the center of this radius, k 2, is the position of the center. I have a few things for later. Discounted. I is the position of the center relative to x. It's the position of the center relative to z. You see, so k will be minus 78. Okay. Look at this beautiful construction he made. He built a structure. But right now, if I don't tell him what to do next, he won't do it. As a result, now we need to tell the machine how it should go to work. He understands that something isn't right, so he accepts the dialogue. Sorry, excuse me, I just need to redo it. I need to redo it. Please let me quickly put all of the necessary information back in. So, R13, I60, K78, OK. Selection, dialogue. You see? It tells me what to do, whether to delete it or not. It gives me suggestions. Suggestions that I can accept or not accept. So he says, but here, Andre, come on. I will still understand dialogue selections, selections, dialogue. I would stop here, accept dialogue, accept cleats, look at some very good looking ones. Now let's go up, and go to X80. Obviously the machine can't understand what to do like this, because it doesn't have an indication. I mean, it knows it has to go to 80, but it doesn't have a real starting point. Do you see these soft keys? Perfect. Tangent to the previous one. Tangent to the previous one, he says, the previous movement was this. So a circular interpolation. I'm moving to X80, starting tangentially to the circle created. We accept, tap. You see it cuts it for me. Perfect. At this point, I finish my profile. Moving to Z minus 100. We accept. And let's go modify this ugly thing. Here. As you can see, it doesn't have a chamfer. I would like to give it a nice radius, just so as not to give the customer a product that doesn't cut their cleats' hands. And we did it perfectly, with great precision and attention to detail. Let's accept and start roughing to the next phase of our project. First of all, of course, we need to select the tool, so here it is, select inventory, interruption, select tools, roughing tool. Okay, it was already within the parameters from the last time we used this tool. And we say, okay, you can work well, very well, but with a CNMG at 80 with an attack angle of 80 degrees. I can't do undercut C, undercut frames. We accept and simulate. Let's see what happens. I'm aware that I had already made a program like this. Always with you? I haven't told you some things about the roughing cycle. Now, just in case, let's take a quick look at it together. Just for those who missed the other one, video, but I wanted to get there first. Here, you can see that our part was made completely ignoring these two areas. Let's go back to edit. Let's go back to the roughing cycle with the right arrow and modify something. Is it okay to rough parallel to the profile? Yes, that's fine. Is it okay to do an external machining? Yes, that's fine. It's fine to do a roughing, because I could use the same tool for both roughing and finishing. The only thing I overdid, which I haven't modified, is the material removal. For each pass, at least 5 millimeters, since we have a nice diameter of 80, and also because it gets long undercut. We told him. No, and we accept and resimulate. This will just make things a little faster, but it won't change anything compared to before. So, our roughing, you can see that it makes more generous material removals compared to before, which is a significant improvement in terms of efficiency and speed. Perfect. I have this roughing operation compared to our previous methods and techniques used in the past. At this point, I would choose between two options. At this point, we could either rough these areas seen as lines or make a modification. A modification in this sense. Let's go. Select the tool. Let's enter the warehouse and say I'm not doing it. So, interruption, let's see if it's from here. Interruption, so select, tools, selection, warehouse, tool list. Here it is. So, let's redo it. Let's take it slow. I got myself all mixed up. Program Manager, Mozzi. So, roughing, arrow modification, select the tool here. You can't modify anything, so just select the warehouse has gone into the tool list. Here we go. Let's go back to the first tool and say, no, look here. I'm not going to use an 80-degree tool, but a 55. You see, perfect transfer less to the program and put me in the undercuts F and R are also the per revolution. When I enter an undercut, it's assumed that when I go into a planted area, I should go a bit slower. Let's accept more and simulate. Here, maybe in reality, it would have been better to lower the roughing depth. You see it's starting to go down, of course, within the limits of the tool. That's great, because at least we've cleared that area now. when we basically go into edit in turning, profile, roughing, and we will essentially tell it. Now, however, actually select 1 for me and literally go do the finishing. Undercuts? Yes. Excess material? No. Parameters are good at 0.3. Per revolution, let's set it to 0.2. Because it's a bit lighter as a tool, and then, anyway, we will establish this based on the surface finish required by the design. While learning, we have the luck of not having anyone watching us. So we say accept and simulate. So now, after the initial roughing phase, the tool will be carefully changed in this process. And the undercuts will be made, which will conform to the design. In this case, it's more appropriate to see it this way. Now it gets to the step. Finishing, and you see that it can make the radius because we can do it. At the limit, we could have easily used a round insert. At the limit, we could have split the shape in two so we could program from here to here or from here to here. There isn't a right path. What's important is that the path takes us where we need to go. And as you can see, our product, it's almost done. Let's go back to edit and head to the end of our program, turning, thread cutting. We have an M24X15. So it has already selected the tool that we need. You see, trading 1.5, table. Let's say an isometric. Let's go and see if the M24 isometric is 1.5. I don't think so. You see it says 3 mm per revolution. So I can't use the table. Then I'll go without it. A pitch of 1.5 per revolution works perfectly for me. The pitch doesn't change. Yes. The pitch doesn't change. Yes. It's the revolutions per minute. So our machining perfect is linear machining. That's great. Otherwise, we can set up a machining process that decreases D1 as it goes down. That will depend on the material we're going to work with. It's an external thread. X0. This point, meaning the start of the thread, is at 24. Z0 is at -16. And we actually give it the Z. What interests us, that is Z -16. The length is 1638. So it's 414. And 822, let's give it at least 20. But extension, here we go, incremental. That's fine. In this case, incremental works well. Otherwise, we could set it to absolute and not have to do calculations and just put in -40. 40, minus the 40. LV. Safety distances, yes, there's also a nice chamfer. So starting at Z13 is more than fine. LR. Theoretically, in this case, we don't care at all, because we exit and leave the 2 mm. H1. If he has already calculated it, it doesn't really matter to us because he does it for us. The insert, D1, is the depth we remove with each pass. U is the super metal we leave for finishing. VR, the tool media that we use to detach when we leave. We accept and simulate. I'll do it later. Maybe the same product, or perhaps a product that's a bit more challenging, made with manual guide. And we'll do it like they do in America. Manual guide was for Sinutrain. And unfortunately, for me, since I was born on Fanuc, but I haven't embraced it. I'm pretty sure that Sinutrain will win because it's really effective as a type of conversational programming. And here we have our fillet ready. This is also an example that can be found in some of the manuals that come with the machine. Then we might also do something different outside the guidelines of the manuals. But with these basic designs, you have a good range of possibilities that you might encounter in real life. I hope this video has been of interest to you as well. If so, I hope you will like it. If you are not subscribed to the channel, please subscribe. And if you want to do me a favor, share these videos on your social networks and with all those who have the passion or need to use a lathe to try to make it spin as much as possible. Of course, I would appreciate that. Thank you all for being here. See you in the next video. Have a good evening.